All right, welcome. Today we are diving into maybe the most important question in any machine learning project, the where. Where do you actually write your code? Where do you train those massive models? And where do you deploy them so the whole world can use them? Well, you're in the right place because we're about to go through the ultimate guide to compute in Azure Machine Learning. So, here's the plan. We're going to follow the entire journey of a machine learning project, right from a simple idea to a real-world application. We'll start at our project headquarters, then we'll move into the development workshop to build a prototype. After that, we'll scale things up in the training factory, and finally open for business at the deployment storefront. We'll even do a quick check on our fuel supply, the data, and wrap it all up with a quick-fire exam to make sure you're ready to build. Let's do it.
Okay, so first things first. Every great project, right? It needs a home base, a central hub that keeps everything organized and in one place. In Azure ML, we call that headquarters the workspace.
I want you to think of the workspace as the main folder for your entire project. It's the big box that holds everything we're about to talk about. All your code, your data connections, and all that powerful compute. It really is the foundation that everything else is built on.
So our headquarters is all set up. Now it's time for the fun part, getting our hands dirty. Let's step into the workshop, where that first little spark of an idea gets hammered into a real working prototype.
So you've got this awesome idea buzzing around in your head, but where do you go? Where do you actually write the Python code, explore your data, and just mess around with things interactively? You need an environment that's just ready to go without a ton of painful setup. So what's the answer?
Well, meet the compute instance. And honestly, the absolute best way to think about this is as your own personal super-powered laptop that just happens to live in the cloud. It comes preloaded with all the good stuff. Jupyter Notebooks, the Azure ML SDK, all of it, so you can start coding right away.
Now, notice a few key things here. It's a single machine, just one powerful VM that's all yours. It's meant for you, the data scientist. And this is huge. You can stop it when you go for lunch or at the end of the day to save money. That makes it the perfect little interactive sandbox for development, writing code, and debugging.
So the takeaway here is super simple. Use a compute instance for your interactive let's see what happens phase, probably inside a Jupyter Notebook. But, and listen up because this is important, it is not for serious large-scale production training, and it's definitely not for deploying a model that needs to be available 24/7. It's your workshop, not the factory floor.
Okay, success. Our prototype is working, the code checks out. But now we have to go big. It's time to move out of that little workshop and build our full-scale training factory.
And this is the classic machine learning problem, right? Your logic is perfect on 1,000 rows of data, but now you have to run it on 10 million rows. Your little cloud laptop, that compute instance, it's just not going to cut it. You need some serious industrial scale power.
And this is where you get that industrial power, the compute cluster. See, this isn't just one machine anymore. Oh no, this is like an army of virtual machines that all work together. And the best part? Azure manages the whole thing for you. It automatically grows to handle your training job, and even more importantly, it shrinks back down when it's done. This is your training factory.
The absolute killer feature here is the auto-scaling, especially its ability to scale all the way down to 0 nodes. What does that mean for you? It means when you're not training, you're not paying. Period. You can even use cheaper low-priority VMs to save more cash. And of course, it's got full GPU support, making it the perfect powerhouse for any heavy-duty job, like training or hyperparameter tuning.
The decision here couldn't be simpler. If you are training a big model, you use a compute cluster. End of story. But if you need an instant, real-time prediction from your model, you absolutely do not use this. Think about it. The factory has to warm up all the machines, right? That takes a few minutes, which is way too slow for a real-time API call.
All right, the factory has churned out a masterpiece. We've got this beautifully trained, super accurate model, and now it's time for the most exciting part, opening our doors to the public and putting our model to work in the real world.
So your model is a finished product. It's ready to go. But how do you actually serve it to a mobile app or a website? How do you create a reliable, secure, and super fast endpoint that can handle thousands of requests from users? You need a professional storefront. And this is your storefront, the Inference Cluster. Now, under the hood, this thing is powered by the industry gold standard, Azure Kubernetes Service, or AKS. And let's be crystal clear, this is not for training, it's not for development, this is the real deal, a production-grade, hardened environment designed for one thing, serving your models reliably and securely.
So why is this the go-to for production?
Well, a few big reasons. It's built for high availability, which just means it won't go down when traffic spikes. It's secure with things like HTTPS built right in. And maybe most importantly, it's designed for low latency, crazy fast responses. We're talking sub-second. It's just perfect for hosting your model as a professional REST API.
So let's drill this in one more time. When you need to serve a model in real time, you use an inference cluster. Never, ever use it for training. It's super expensive and just not what it's built for. Honestly, for simple dev and test deployments, it might even be a bit of overkill.
Okay, deep breath. We've got our workshop, our factory, and our storefront all planned out. But, none of them can run without fuel. And in our world, that fuel is data. So let's take a quick look at how Azure ML handles that.
Okay, this can be one of the most confusing topics for people, but I promise this analogy makes it so simple. A data store, just think of it as the saved password for your office Wi-Fi. It's just the connection info. You set it up once and kind of forget it. A dataset, on the other hand, is like a bookmark to a specific web page. It's a pointer to the actual data you want to use. So you use the password, the data store, to get to the page, the dataset. Simple as that.
All right, you've seen the whole assembly line. Now let's lock in that knowledge with a couple of rapid-fire questions, the kind you might actually see on a certification exam. You ready?
Okay, first one. Think back to our training factory, the compute cluster. You've submitted a job and you want to be as cost-effective as humanly possible. What should that minimum node setting be? I'll give you a second.
The answer is 0. You set min nodes to 0. By doing that, you are basically telling Azure, hey, the second this job is done, shut the whole factory down completely so I don't pay a single cent for machines that are just sitting idle. This is the single most important setting for managing your training costs.
And there you have it, the compute instance for your workshop, the compute cluster for your factory, and the inference cluster for your storefront. The entire journey from that first spark of an idea all the way to a production model, mapped out. You have the blueprint. The only question left is, what are you going to build first?